Okay, so today's topic, Future Thursday. So we're going to take something in the seventh grade curriculum. Today is, or the lesson for today is Thursday, 11/17. So we're going to take on proportional relationships. Now we didn't get through all of these in class, not even close, but I'm just going to go ahead and do it all. That way it's out there for you to go over. You can fast forward, rewind, pause, stop, whatever you need to do. That's what these lessons are for. So you can do it on your own time if you need to. Okay, so we'll go ahead and get started. Number one, Amy drove to her mother's house, which is 204 miles away, for 3 hours. How far could she travel in 5 hours if she traveled at the same rate? So let's think about this. There's two ways I'm going to show you to solve this problem. The first way is sort of the common sense way. So if we know that she drove 204 miles, okay, and we know it took her 3 hours, okay, we can divide 204 by 3, okay, and that is going to equal 68. Now, what does that 68 mean? Okay, so she drove, it took her 3 hours to drive 204 miles. So what that means is, if we divide the total distance that she has driven by the number of hours, then we get her miles per hour rate. So she drives 68 miles per hour. That's how fast she drives. Well, the question is asking, how far could she travel at the same rate in 5 hours? So if we know in 1 hour, because that's what miles per hour means, it's the amount of miles traveled in 1 hour, we know if she traveled 68 miles per hour and she drove for 5 hours, then that would be, I believe, 340 miles. So 340 miles in 5 hours. So that is kind of the common sense way to solve the problem. You just figure out the rate that Amy is traveling, and then you just say, well, she travels that rate for 5 hours. So there's another way, and I'll show you, kind of block this off. Since we're actually exploring proportional relationships, which we use proportional relationships, we use the relationship 68 to 1. So 68 miles to 1 hour is a proportional relationship. But there's another way we can do this, and it's a method called cross multiplication. Now, the way you do cross multiplication, if you can set up a ratio from the information given. So the first ratio that we set up, and we were given this information, is 204 to 3. So 204 over 3 means she can travel 204 miles in 3 hours. Okay? Now, and here's the part that you have to kind of wrap your brain around. We know that proportions, we're representing this proportion as a fraction here. They are basically synonymous. They mean the same thing, a fraction and a proportion. There are some circumstances where they differ just slightly, the terminology, but essentially you can view a fraction as a proportion. So we know that she's traveling at the same rate, okay? So what that tells us is whatever proportion of miles traveled to hours spent traveling is going to be the same. And we know fractions can look different, but they can be the same. They can be the same number, okay? So they've given us the 204 to 3. Okay? They gave us some more information though. They gave us 5. That's what they want to know. Now what we know is that if she travels 204 miles or she travels some other distance, she travels at the same rate. They actually said that. She traveled at the same rate. So our proportion of miles traveled to time spent traveling is going to be the same. So we know that there is some number of miles that can be traveled in 5 hours, and when we write it as a proportion of miles traveled x to hours traveled 5, we know that proportion will be the same as 204 miles to 3 hours. Okay? Now, once we have this equation set up, we can do something called cross multiplication to set up a new equation, and then we can solve for the variable. Okay? Now, we haven't solved for too many variables. Some of you are familiar with it. A lot of you have been over it in previous years. So that part might be new, but just try to follow along. Again, this is Future Thursday, so it's not, we're just getting exposure to it, and we're seeing different ways to do things. So cross multiplication literally means you multiply across. So what that means is 3 times x, which we just write 3x, then we put an equal sign, and then we multiply across again. So 5 times 204. Now you may recognize this. This is just an equation with a variable on one side, and we can isolate the variable to solve for the problem. So the first thing we do is go ahead and rewrite 3x. Let's go ahead and multiply the 5 times the 204. So 5 times 204 is 1,020. Well, if we know that 3x equals 1,020, we can isolate our variable by dividing. Let's go ahead and rewrite it down here. So do a little math. We know that we can isolate this variable by dividing this side by 3. So 3x divided by 3, these 3's will divide to 1, so we're left with x. But we must remember, if we have an equal sign, if we decide to do something to one side of the equation for a certain reason, in this case this reason is to isolate the variable, we must do the same thing to the other side of the equation. So we must divide both sides by 3. And indeed, if you punch it in your calculator or do it longhand if you wish, 1,020 divided by 3 does equal 340. So the first way we did it is fine. There's nothing wrong with that. It might take a little bit more time to figure out the rate and then use that rate, but it's a little easier to think about. The cross multiplication is more of a method that you just learn. It would take a little bit longer to explain exactly how mechanically it works. You can definitely think about it for a while. It does make sense, but it's just a little bit more of an in-depth explanation as to why it works exactly, or just the mechanics behind why it works. So that is problem 1. So let's move on to problem 2. I just dropped the pen on the computer. So let's go ahead and give ourselves some room here. So problem 2. So what they're telling us is Rick renovated his home. He made his bedroom 40% larger in length and width than its original size. If the original dimensions were 144 inches by 168 inches, how big is his room now if measured in feet? So Rick starts out with a bedroom that looks kind of like this: 168, 144. So this is the dimensions of his room. Now we must increase these by 40%. So I'm going to go over 2 ways to do this. So any number that you know that you want to increase that number by a certain percentage, we essentially need to find out how much is 40% of that number. So for instance, if we want to increase the 168 by 40%, we need to find out how much is 40% of 168. Now, if you'll remember, I'll write this out to the side here. 40%. So how do we can't multiply by 40%. I mean, we can, if we have a calculator that works that way, that has the percent function, but typically we're going to want to convert the percent into a decimal. Okay? So what we do in every case is we just write the percent and we pretend that there's a decimal here and we move it 2 places to the left every time. Okay? So whatever number is a percent, we move the decimal 2 places to the left, and that gives us our decimal. So in this case, 0.4. So 0.40, or we could write 0.40. You see that a lot. That is optional. If you want to write the initial 0, just make sure that you know that it's 0.4 or 0.40. So now, all we need to do is multiply 168 times 0.40. That's going to give us 67.2. Okay, so if 168 were to grow by 40%, say we want to add 40% of 168 back to the 168, we're just going to add the 168 and the 67.2, which gives us 235.2. Okay, so we can already tell what our answer is going to be. Okay, because we've arrived and there's no other option to have one of the links be 235.2. So you would do the 144 the same way. You would just multiply it times the 0.4. Instead of 168 here, you would write 144. You would come up with a different number here, and you would just add it back to the 144. So pause and do that on your own if you wish. It's probably a good idea to go ahead and do it, just get a little practice, and then make sure that you come up with 201.6. Okay, so, but there's actually another way, and a little quicker way. So we can take one of the dimensions, and this goes for any number you want to increase by a certain percentage. Okay? What we can do, we can multiply it times 1. Okay? Now, what does that do? We're not just going to multiply it times 1, but just bear with me. So what does this do? 144 times 1 is 144, right? So if you'll remember back to our initial problem, we added this back to our original 168. Well, essentially multiplying the 144 times 1 will give us 144, so it keeps the 144 with us without us having to find out 40% and then add it back to the 144. We just go ahead and multiply it times 1, but then we add in the 40%, so it's actually going to be 140%, or 1.40, okay? So you just take whatever percentage, we converted it to a decimal, you tack on a 1 whole number, and then just, it's 1.40 times 144, or 144 times 1.40, and what we have is 201.6, and indeed we can see 201.6 is our number. So kind of two methods. One is a little bit more intuitive, a little bit more common sense. The other one takes some thinking about, but you can understand how it works if you just know that initially you're multiplying it times 1 just to keep your original quantity inside your equation or inside your problem, and then just by the nature of multiplying it times 1.40, you wind up with an increase of 40% already added to your base, to your initial amount. Okay? So, number 3. So, Lauren takes 12 hours to read a 360-page book. At this rate, how long will it take her to read a 400-page book? So again, this is one of those where we have established a rate. Okay? So, this rate is 360 pages for every 12 hours. Now, we could, just like before, we could divide. We could go ahead and divide the numerator by the denominator, the top by the bottom, and we would come up with a rate per hour of how many pages per hour. So 360 divided by 12, she does 30 pages per hour. So 30 per every hour. So that one would be a little different. This one actually will be easier to do with the cross multiplication method. Well, not really easier, maybe easier to understand when you're sort of first doing it, but they're asking us not how many pages, but how long. So we have to find the hours. So if she can read 30 pages in 1 hour, we would divide 400 by 30. So we know every hour she's reading 30 pages, so we can just divide 400 by 30, and that should give us our hours. So let's go ahead and do that. 400 divided by 30. .33 repeating pages. Or excuse me, I'm sorry, 13.33 hours, so 13 1/3 hours. So now if we were going to change this, that would be 13 hours. We know .333 repeating is actually 1/3. So we know that there's 60 minutes in an hour. So if we want to convert this to hours and minutes, we would just take 60 and we would multiply it times .33333, and we would get something like 20 minutes. Okay? So 3 hours, or 13 hours, 20 minutes. 13 hours, 20 minutes. Okay, so let's set up our ratio for cross multiplication, and let's try this that way. And I think you'll find this is a little, once you get the hang of this, this is a little quicker. You just have to make sure that you have like units on the top and the bottom. So in this case, we're having the pages on the top and the hours on the bottom. We don't know the hours, so we put in an x for our variable. We can cross multiply, so 360 times x equals 12 times 400. Running out of room. Yeah, let's move that. Okay. So 360x equals, and what is 12 times 400? 12 times 400 is 4,800. So if we want to isolate the variable, as in get the x by itself, we're going to divide by 360. Again, we divide both sides by 360. We know 360 divides to 1, so we're just going to have 1x now. And let's see, so 4,800, and indeed 13 1/3, or 13.33 repeating hours. So that's both the ways. The common sense way that you can kind of think your way through is figure out how many pages she reads in an hour, and then once you know how many pages she read, you can determine how many hours it took her just by dividing. Okay? Or you can use cross multiplication. So let's go on to 4 here. So which is the best buy? 6 shirts for $25, $25.50, 4 shirts for $18, or 5 shirts for $21. So what we want is we want to figure out the lowest cost per shirt. Okay, that would mean that you have the best buy. That means you're paying the least for each individual shirt. Even though we're buying different quantities of shirts, we want to figure out how much for one shirt. In what way can we buy the cheapest shirt? Okay? So, what we need to do is just take the total amount of money in each scenario that we spend and divide it by the number of shirts we received. And the lowest number will win. The lowest price will win. So we're just going to set them all up here. So just to think it through, you hand the person $25.50 and they give you 6 shirts. Now, you've paid so much per shirt. We can determine a per shirt price. And the way we do that is divide $25.50 by 6. That's going to give us, 50 by 6. That will give us $4.25 per shirt. $4.25 a shirt. All right, so let's just continue on. 18 divided by 4. $4.50. So I got 4.5 for that, which translates into $4.50. So 21 divided by 5. $4.20. So I have 4.2. 21 divided by 5 is 4.2, which translates, when we're talking about money, we're talking about dollars and cents. So 4.2 is $4.20. So we look, that's per shirt, per shirt. So $4.25 is less than $4.50, so that's a good candidate. But $4.20 is less than either one of them, so 5 shirts for $21 is our best deal. That's the best buy right there.